Okay, so I think we'll get started now. Welcome everyone to our Fireside Chat series. I am one of your co-hosts, Noah Abrahams. I'm the open source advocate here at Stormforge. With me, as always, is my co-host, Cody. Introduce yourself, please.
Hello, Cody. I'm a senior consultant here at Stormforge.
And with us today is our inimitable guest, Kris Nóva, senior principal software engineer at Twilio. Ta-da! We will be using Q&A throughout this session. So if you have any questions, please dump them in there instead of into the generic chat. And let's get started. So let's start. Kris, why don't you start by telling us a little bit about yourself and tell us a little bit about how you got started in this whole infrastructure direction.
About myself and how I got started in this whole infra direction. Hi, I'm Kris Nóva. I work at Twilio for my day job. I'm an engineer here. I'm at my house, but I work at Twilio, but here is now work. And yeah, it's all related to my career. And I think Linux and computers has always been something I was passionate about. And I found out at a young age there was money to be made there, and money is a thing that you need to survive in this country of ours. And so yeah, so anyway, I figured if I could survive while also doing something I loved, that would be great. And anyway, infrastructure was something that I was passionate about very early in my career. My first job was working at a do-it-yourself, roll-up-your-sleeve software engineering job. I wasn't paid very much. We were writing code in the back of a warehouse. We had once been like a tool shop, and then we turned into an online store. And needless to say, we had good ideas. We wrote good software, but we didn't have any DevOps. This was before the day of DevOps, before anything else. So our servers were old recycled computers from our marketing department that we stuck in a server room and tried to build infrastructure on. So I think from an early age, including my personal life, computers were fun. Getting computers to work the way I wanted them to and to be set up in a way that worked well for me to have fun with was always a big pain in the butt. And so I found very early that I could do this thing of using computers to make other computers be less horrible for myself. And then, I applied that at my day job and found myself I think you see this really conceptually, but I wrote a bash script, right? I was able to use computer science to do things to make the computer easier for myself or for other people to use. Anyway, as I grew in my career, that problem never seemed to go away, but my ability to craft computers and craft systems of computers dramatically grew and scaled, and technology has come like Kubernetes. And I'm still solving that same original problem of computers just suck and I'm trying to make them better for myself and for teams of people, except for now I'm doing it I'm in charge of designing fleets of very, very expensive computers and data centers that do a lot of things. And everything from how does the computer get into a rack and how do we make sense of that, all the way up to do we have an HTTPS API listening that's available to the public internet, and everything in between. So that's kind of my TLDR, and my resume is littered with a ton of jobs. I worked at Microsoft on Azure. I worked at VMware. I was part of Heptio. We were a lot of the original Kubernetes folks there. I'm sure I'm forgetting other things. Oh, I was at SolidFire, and we went through acquisition into NetApp. So low-level software engineering, pretty much my whole career.
Awesome.
Yeah.
Sweet.
And I think that's a pretty good segue, actually, because you've spoken a lot and written a lot about Kubernetes and written an amazing book, which anyone attending should probably check out.
Yes, you should buy several copies of Cloud Native Infrastructure for your friends, immediate families, and their friends and their immediate families today.
So you've talked a lot in there about Kubernetes, and when we were setting up this talk, you were talking about how Kubernetes approaches problem solving and system management, and how that's something that is, that's interesting, that how it approaches those particular areas. So let's talk a little bit. What can you say are kind of the takeaways from Kubernetes with the amount of time that you've spent in there on how we're approaching infrastructure and infrastructure design? Like, how do we lead into this?
Yeah, totally. Okay, so like real quick, let's start with Kubernetes, right? So Kubernetes is successful because it attempts to at least abstract what I've been struggling with my whole career. From an application developer's perspective, Kubernetes is the ultimate API. And it's a little weird at first because you're like, why does it like look and feel this way? And it's because it is a good abstraction over infrastructure. If you look at computer science, right, up here on my bookshelf, I have a copy of CLRS, which goes deep into algorithm design and runtime compute management. But then, there's other books on my shelf that are more about, networking stack, the OSI reference model, right? And computer science can fundamentally be broken down into 2 or 3 or 4 main pillars, all of which I feel like Kubernetes abstracts away. And Kubernetes did a really good job at abstracting container runtime, which is like a compute resource, and abstracting storage with CSI, and extracting network with CNI, and bubbled all that up to the user and said, okay, you're an application developer. Here's what you need and how you need it in a way that's meaningful for you to understand. Which is great, and we needed that. Every engineer who has been in the business for the past 3 to 10 plus years has felt the pain of trying to deploy applications and it not being fun, especially at scale. That's just a hard problem to solve. Kubernetes took a way of managing that from the top down. Now, let's flip that around and let's take Linux, which Kubernetes is built on. It did the complete opposite. It went from the hardware up. It said, let's abstract the hardware and point it up towards this place we called user space. And user space is you're SSH'd into a terminal. And we now have these hardware abstractions where if you want to explore a block device, there's ways of doing that. If you want to mount a block device and you want to go explore it and using the Linux file system, you certainly can. And it doesn't really matter what hardware you have beneath. It doesn't matter if it's a solid state drive or a spinner or whatever. It's all abstracted. Kubernetes did that the other way. So we're left with this really annoying neglected user space in the middle between these two abstractions. And that for me is that's my job, is to make that less annoying. And I really the more I learn about the software engineering side of why Kubernetes did what they did for application developers, the more I appreciate the constructs, and yet again still find myself struggling with this ugly middle layer of what is user space and how do you glue together these two abstractions that are meaningful for completely different perspectives.
Okay, right. So a lot of complex problems that still need solved, right?
Yeah.
Easier on one side, a little bit harder on the other. There's this, like you were saying, there's still this gray area that we have. Today's talk, we're focused on infrastructure as software, not as code. So for our audience, can we just define infrastructure as code now before we segue into the other things?
Yeah. So this is a hard problem, right? I feel like this is a very personal question. It's like asking, what does DevOps mean to you, right? And DevOps might mean different things to a dev. If you're a DevOps engineer and you find value in that and you've been burned by that, that's a personal thing, right? Like we were talking earlier about the type of people who drive trucks. That's a personal choice that you you wake up one day and you're like, I'm gonna be a truck person. And I feel like DevOps is kind of similar. I'm going to be a DevOps person. I feel like infrastructure as code kind of follows the same idea. So to me, there's a difference between what I would call code or configuration management or a scripting language versus what I would call software. So a really good example of this is the difference between a bash script and a compiled binary. And there's some runtime discrepancies there, and there's reasons why you would use one or the other. But I think that the paradigm remains the same of code is this like, it's a representation of like what you hope to do. And software is more of a, given these well-known constraints, we absolutely will do these things under these certain circumstances. And so when I look at the state of infrastructure over time, I learned that we're actually just about a decade behind software. In other words, 10 years ago, software management was when we were running virtual machines. We were writing monolithic Java applications and object-oriented programming languages. Every engineer getting a job walked into that, engineering interview with, I understand the 4 tenets of object-oriented coding design. I know what polymorphism is. I know what abstraction and encapsulation is. I haven't said those words in my career in 5 years. And a reason for that is because the software industry has changed. And anyway, if you look at our deployment mechanisms, I think infra is kind of hot on the tails of software engineering. And so for me, there's a big difference between writing down, let's take Terraform configuration or Puppet or Ansible, and let's write down, hey, I want a virtual machine and I want you to run these 12 bash commands on it. And I want to, make sure these 8 packages are installed. And that's a great starting point. That's certainly a lot better than like walking into the server room and, plugging a keyboard in and turning the monitor on and typing apt-get install package and hoping that, that computer, which was built 2 years later than the other computer, will just magically work the same way. So we've definitely come a long way. However, we noticed in software that like that's kind of a one-time thing. Like there's this concept of one and done, this concept of throwing the ball over the fence, of typing Terraform apply, or getting a stack to chef, right? We've all said this before. And what happens afterwards, right? It's easy to create the infrastructure, but how do we manage it? The management isn't always quite as simple as we think it is, because things happen. Software likes to write things to the disk, disks break, networks are changed, there's security incidents that causes like other teams to do other things. And when the complexity of your infrastructure grows with the size of the amount of people working on it, the size of your company or your team, it's not as simple to reconcile a lot of that management. So infrastructure as software to me is a means to an end for how we manage it after it's up and running. We have software that is running, that is looking at it, that is continuing to reconcile it over time. And the whole, like, this isn't new. This was not like a new crazy thought, Kubernetes has been doing this for 6 years, right? This is robotics theory. This is a well-known pattern that we see all over computer science. We've all seen a systemd daemon before. And what does a systemd daemon do? It's just a loop that runs and tries to reconcile things over time. And I'm just saying, like, that's a really good engineering pattern, and we should probably apply that to our servers and our network and our storage and all these things we as infrastructure people struggle with. So to me, infrastructure as code gets you up and running quickly, which is the problem you want to solve, but it also allows for a ton of drift from that original state of starting. Infrastructure as software is the idea that I don't ever mutate anything manually. I write software to make it reconcile from an unknown state to the state that I want it in. And so that's Kubernetes, right? And all I said was like, hey, we can learn from the application guys and we can start managing our infrastructure the same way. So to me, that idea was very clear. And I've actually found that it's not always that clear and that simple when I'm entering a lot of these infrastructure conversations, right? And a lot of folks, I think, I found, myself included, would find great value in just slightly changing the perception of what it means to manage infrastructure versus what it means to create it. So that's my diatribe anyway. I don't know if y'all have any thoughts on that, but that's kind of what it means to me.
I have a thought on that around sort of the people involved in that process. So it feels like you're saying that there is basically just a lag between the infrastructure folks and the software folks and the theories that are being put in place and the tools and techniques that are in use. But I know from a stereotyping perspective, folks on the operations side, the folks that typically control infrastructure, tend to be a bit more, I don't want to say resilient, but more cantankerous. They've got their thing, they know it works, and they don't really want to move on. Historically, are you seeing, from your point of view, a lot of change of people taking these new principles that were already developed in the software industry and applying them to infrastructure? You're seeing a change in the mentality of the people that are working with infrastructure to be able to adapt that and bring it in, like with the rapid adoption of Kubernetes.
Absolutely. It's a change in thinking. And with this change in thinking comes a change in the systems we use and we count on and how we think about our systems, right? Like there's a big difference in my mind in saying like, I bought a daily driver to get me to and from the office every day. And I bought a car that was reasonably priced so I could drive it across the country twice. You might buy the exact same car. You might sit behind the exact same steering wheel, but the mentality of what you do with the car is going to dramatically shift. So I feel like we're seeing that level of, it's the same tools and technology we are all familiar with, but we're reframing what we're using it for and how we're thinking about it. And that is actually causing some pretty dramatic downstream effects. I think one of the most really fascinating downstream effects is something that we're seeing today at Twilio with the work that I'm doing there, which is most infrastructure orgs or most infrastructure, even if it's one person, like let's take a small team of engineers that's got like a DevOps guy, right, or an infrastructure lady, right? Let's take that scenario and let's look at the job and the work and how it's generated for the infrastructure engineer. It's typically a reflection of an engineering need. So fundamentally, the culture is it's rewarded in the workplace for engineers to be creative. Engineers are rewarded for generating work and generating ideas. They say, you have an idea to solve a business problem, we will reward that. That's good behavior, throw you a bone, right? Good dog, right? And so infrastructure engineers have a completely different set of rewarding and a different set of success, which is how do I enable the ideas of and the work generated out of the engineering work, right? We're a means to an end. We're a void that exists because of another problem. And so that is true. And that's why I got here in the first place, is because it's always been a problem. And anytime there's a problem, there's an opportunity. So I just took advantage of this opportunity. And if you look at infrastructure teams today with this, if we're writing software to manage our systems, we are software engineers. And this is the first time that architectural design and the business rewarding that is coming from the infrastructure org instead of being handed off, sort of like through a second degree generation of work. So I think what we're seeing is we're seeing people who have traditionally found value in solving really, really hard, complicated problems for engineering orgs for the first time, imagining what it would feel like to not only identify their own problems, but also offer a software solution on top of that as well. And that's a big change in thinking. That's like something you take home with you every day. And that is something that like you for me, like I talk to my partner about it. Like we talk about this type of stuff often because it's so fundamental to like, how you make a cup of coffee in the morning, right? It's just this idea that goes with you. So I do think that we're seeing a change in thinking, and what we're seeing systems reflect that. And going back to the car analogy, it's ironically still the same systems we've been using this entire time. Yeah.
So early adoption, right? It also lags behind, whatever, especially, maybe not so much startups and product teams there, but or infrastructure teams there, but when you're talking enterprise and big business and things like that, they typically lag behind 10, 15, maybe even 20 years, right? What's the path to get from this infrastructure as code to infrastructure software, right? You say it's a change of thinking, and like Noah was saying, right? They don't want to give up their toys that they just learned and they've gotten certified on and they're comfortable using. How do we push this progression? Because it does seem like these frameworks and these constructs that have been in place for years, like you were saying, Kubernetes did it. What's the right path? How do we get there?
So like let's go back to the psychology of how work is generated. The reason infrastructure folks are typically reluctant to give up patterns that they have found success in is because there's a good chance they're getting a lot of like, hey, I have a problem, fix it, right? Like in a world where the infrastructure their entire job is to fill a void that exists because of another org's needs. That whole cultural relationship is based around the, hey, I have a void, fill it. And so if you're getting a ton of requests for like, hey, I have a problem, hey, I need a server, hey, fix my network, hey, the storage isn't big enough, hey, we need more disks, hey, I want to try this new database, hey, this new database is too slow, right? Like every DevOps engineer is like going like this right now because we've heard this a million times. And that's because that's the culture. And so I think the reason that we're reluctant to change our toys is nothing more than like we're just reluctant to engage in any more chaos, right? So it's basically like saying like, I'll say no. It's like, I hate to say it, but it's like a, private healthcare, right? Like default no. We're going to default deny everything out of the door just because like we want to see who's going to yell the loudest, and then we'll give those folks the time of day. And like, unfortunately, that's a very reactive defensive technique that is like, it's effective, but it can be like, if used inappropriately, can be harmful. And so like, I think, when we're looking at tools that people use every day and how do we get them to change it, I think that cultural shift isn't something you can give anyone. It comes from within somebody's approach to how they solve their problems. There's a big difference between, hey, I need a server, go create a server for me, and saying, oh, sure, what do you want your server to look and feel like? Which that makes everybody happy. That feels good, right? That people look at that and say, hey, you're doing great. The engineers say, hey, I got what I need. And everybody says, yeah, hey, we're having a party. And then like fast forward a year and every infrastructure engineer is going over here and go, holy shit, how do I manage this? I gave everybody what they needed. And now I've got Ubuntu and Fedora, and I've got this IP block over here on this subnet, and we're using a completely different routing protocol over here, and we use switches here, and we're in Amazon over there, and there's just so much chaos and complexity that this is unmanageable. And surprise, here we are, day 2 infrastructure operations. This is what happened. And so like, I think it's this idea that you're not necessarily saying no to the request, but you're just challenging if they want it in the form that they are asking for. It's really easy for somebody to say, hey, I need a server. It's really easy to give someone a server. It's really hard as a person to say, do you need a server or do you need a MySQL database? Right. And that's the question. And more often than not, I've found a small amount of kindness, a small amount of thought, and a small amount of listening can turn those, hey, I need a server and I need it now conversations into, hey, I need a database and I'll take it in 6 months. And I think that's the change. That's the change, and that's how you get the software to change, and that's how you get the systems to change, is by changing the culture. Systems are a reflection of culture, right? Everybody is mad at Jenkins because Jenkins is where we go to automate things. We're not mad at Jenkins. We're mad at our ability to continue to like shove things into Jenkins. It's like everybody says they hate city life, but they don't really hate the city, they hate cars. Cities are crowded because there's cars. You can't walk around a city because of parking. You can't find parking because there's other cars. Cities are loud because of cars. Cities are dirty because of cars. People don't hate cities, people hate cars. People don't hate infrastructure management. People hate the things people do with infrastructure management. And so like, I'm trying to say that's the change. You can use Puppet, you can use Chef, you can use Ansible, you can use Terraform, you can use Kubernetes. These are all fine. However, like, we need to think about when we use them. That is the change. That's the change that I am really saying here. And I think thinking of yourself as a feature-driven team instead of a reactive-driven team, that's the difference between infrastructure and software and infrastructure as code. Instead of saying, here's your server that you asked for and I'm going to give it to you today, you say, our next release of software will include an API that will give you the capability to be self-sufficient and get a server on your terms. Please stand by for further updates. That's the change. We're still making servers. We're still creating servers, but we're just changing the language and how we communicate about servers. I'm Kris Nóva. Thanks for coming to my TED Talk, right? Like that's.
Okay, so that brings to an interesting question, because you're talking about how these things are all interacting and how you're using them. leading into another topic that you brought up about placement of pieces as a kernel and things like that, are we making a differentiation here between software, this sort of platonic ideal of software, and the concept of an operating system? Are we making any differentiation between those two in how we're approaching applying these principles to infra?
Yes and no. That's a really, really darn good question, because like one person's infrastructure is another person's user space, right? Like it's just kind of like that's how the stuff trickles down. You know, I might be an application engineer who wants to get my little application into a container, and that's all I know, and that's all they should know. And that, you know, that container is my world. And then that container sits on top of 12 other worlds that go all the way down to like an actual electrons going across a motherboard. And so the operating system can re-represent itself many times, compounding in that stack. You might see an Ubuntu operating system in a container that runs on a virtual machine running Fedora, that runs on a VMware hypervisor. And right, and you know, all three of those different operating systems have concepts of kernel abstractions and how to integrate with hardware. And like if you throw a Java virtual machine or eBPF in the mix, like enter yet another virtual machine that gives you full Turing complete capabilities that are abstracted. And there you go. Like we're reinventing the same wheel in different abstractions over and over again. So it's software to me comes with the paradigm of a software driven workflow. Code to me comes with the paradigm of GitOps, of you know, put it into Git, and that's much better than having a bash script on Mike's computer. And that's absolutely better than having a bash script on Mike's computer. But we still aren't writing tests. We still aren't doing feature releases. We still aren't working as like a service-oriented engineering team, right? We're still just, you know, we can do a Git push whenever we want. We'll push it live and things will change, and we solved the problem of today, and at least we're solving the problem of today in a repeatable way. But it's not, we're still not doing a you know, this is 1.0, this is 1.1, this is 1.2. So the operating system absolutely goes into that. How we keep our tools upgraded absolutely goes into that. And there's so much prior art of all the different ways you can manage different operating system versions. And, you know, an operating system, they have their own release cycle, right? Just like we should have as an infrastructure team. Ubuntu comes out every couple of months. Arch Linux does rolling releases. You know, every morning I can upgrade my kernel and get the latest kernel patches. Not every OS does that. So there's different patterns. Do you do quarterly releases? Do you do releases? Do you do daily releases? Do you do when they come? Do you take the Arch Linux model? And we can borrow all of those. It's the exact same pattern, except now we're just applying it to your virtual machines, your networking, your storage.
Interesting. So let me ask this. In some of the notes, you know, we tossed back and forth. I think in there you mentioned cluster API acting as the kernel. Can you dive deep in that a little bit?
Absolutely. My first task in Kubernetes was please get Kubernetes up and running. In fact, Kelsey, Joe, and Brendan wrote a book called Kubernetes Up and Running, and it was published, like, I think the same year my book was. I think it's 2017. I want to find it here. Yeah, September 2017, right? So this book's it's older, but the point is like we had to go through this. We had to get Kubernetes up and running. And what we found was that we had that same problem we've been facing that every infrastructure DevOps engineer faces, which is infrastructure is hard. And so when we looked at cluster API, this is a reflection of us managing infrastructure at scale. Every company I worked at, like I worked at Amazon Kubernetes, right? AKS. I wouldn't say if I'm proud of that by any means, but like I worked there. And so that was my day job. That's where my paycheck came from. And our use case was how do we stamp out Kubernetes clusters? Like how do we mass produce kube clusters? And all of this went into my book, Cloud Native Infrastructure. It went into the work I did in COPS. It went into the work I did in Kubicorn. It went into this idea that like we need to be a how do you deal with a ton of requests coming your way in open source software? How do we deal with it in Linux? How do we deal with it in the Kubernetes management itself, right? The Kube community. How do we deal with it within any open source project? We have stable releases, and we offer we value standardization over customization. We say that if we start responding to every request, we're going to be buried over our head. And all we did with Cluster API is just basically say, now how do we approach that in a Kube native way? So in the same way that Kubernetes is a kernel for your team, Kubernetes can equally be used as a kernel for a software engineering team whose job it is to manage infrastructure, right? Think about it. If we're a software team, we do feature releases, we need to write code, code needs to manage things, we have to bundle up services and applications, we have to version them over time, we need tests, we need to run it somewhere, and we need standardized way of running it. And if you were to assess the state of the software engineering ecosystem today, 2021, the year of our Lord, what is the best way to go run enterprise applications? It's actually the very same problem we're trying to solve, and thus Cluster API was born. And it wasn't, in my mind, it's nothing. It's effectively, it's meaningless. There's nothing there. There's literally nothing to it. It's just the idea that like we're now using Kube to manage Kube. That's not a very profound thought. However, when you actually look at the similarities of what people need to do while managing Kube, there's actually a void in what Kubernetes offers and what we needed. And that's where a lot of these tools like Cluster Cuddle and Cluster API itself, and the concept of a machine as it compares to a node, all of this came into this idea that we should be using Kube to manage other Kube clusters. And yeah, like it's your kernel. If you need a web service to help you with infrastructure, Kubernetes has this really cool concept of services. And if you need to, TLS encrypt it, there's tools like Cert Manager. And then all of a sudden you're like, oh, we are just a Kube native team. But our use case is not to build the business app, it's to build apps to help enable people to build other apps. So anyway, that's Cluster API as a kernel is just it's nothing more than saying Kubernetes is a kernel, and we're just a regular software engineering team like everyone else.
In that context, that absolutely explains the Cluster API logo of turtles all the way down.
Turtles all the way down, baby.
Oh, wow. So if that's the kernel, where do you think, I just want to get your opinion on this. Do you think Kubernetes leans more towards the software or the operating system side of the house? I don't know why that was weird inflection, but it was. Oh,
no, you're fine. Kubernetes does a great job. Like here, I'll do the psychology theme here. Kubernetes does a really great job at creating meaningful systems abstractions for application engineers, which is a really fancy way of saying Kubernetes gives people who write code what they want and what they need and on their terms. Put your container image here, press go, shut up and don't worry about anything else, right? Like that's what a software engineer wants. And as any person who is trying to deploy an application to an enterprise fleet of Linux servers, and somebody walks up to you and goes, well, so yeah, I noticed you're using this library. Unfortunately, we run x86 in our data centers, and this is compiled for a different architecture. You're like, I don't care. What does that mean? It means your software you wrote won't run in production. And it's just kind of like why do I care about that? That's not my job, right? But it has to be somebody's job. Somebody has to solve the problem. And so that is why I think Kubernetes gives you what you want as a developer on your terms. And anyway, I think that was great for the developers, but I think that came at a pretty handsome cost of neglecting what we traditionally have called the operating system. And I did like a white paper on what I called the distributed operating system void, which I think there's a huge void here. I think there's a huge void in how Kube even approaches different tenets of computer science at the operating system level. Like if you look at the kubelet, the main work engine of every Kubernetes node, it has a concept of storage drivers, but networking is out of scope. Okay, but so how do we solve networking? A completely different install management and paradigm than storage. And it's just like, does it really need to be that way? And if anybody actually gets down and looks at the implementation underneath Cube, all a daemon set is just a glorified bash script, right? Like all of this is just like paradigms we've been doing, but it's just wrapped up in so many layers of abstraction, it feels better. And but yeah, we're still, like, if you look at CNI, there's little executable binaries and /opt that like spit out JSON, and that JSON just always comes in the same form, and that's what we call container networking. However, storage works completely different than that. And container runtimes, like that, we call it OCI compliancy, but it's just like Docker was not built for this, and so we had to like create an abstraction for it. So I look at the operating side of Cube as like, that's the Wild West. That's the clusterfuck, for lack of a better term, right? That's where all of this comes in. Of like, how do we manage the kernel? How do we not manage the kernel? How do we manage networking? How do we not manage networking? That is very, very to be determined by you and your team. And I think we're at the point now in Kubernetes where like we've neglected the operating system long enough. We should probably start taking more ownership of what that looks like. Ubuntu, Fedora, all of these different Linux operating systems are built on the paradigm of having a single user use it. Nobody really built Linux for enterprise applications like this. And I think it's time we start looking at what we actually need in the kernel. We don't really need calendars. We don't really need users and groups and permissions so that multiple people can work on the same Unix system anymore. This was all built for a different world. What we need is we need access to the kernel, and we need good networking. And that's really what we need. And it's unfortunate that we have to do that through this really noisy, convoluted, user space driven Linux world that we have today.
That's very interesting. So we talked earlier, and it keeps coming up. We have abstraction after abstraction after abstraction after abstraction after abstraction.
Yeah.
Is too many levels of abstraction too much?
I mean, I think so. I like, just to answer that question plainly. Yeah, I think so. I can talk more about like let's look at eBPF in networking, right? Like right now, if you deploy a pod in Kubernetes, it needs a network. It has to be able to talk to other components. Even if Kubernetes is running on one node, it still uses localhost to communicate to itself. There's just different components that need to like route over some concept of networking, whether it's a real network or not. And all of that has to go through IP tables and usually route tables. And there's usually, just in the networking stack alone, there's several layers of abstraction. So if you look at eBPF, that kind of just bypasses a lot of these layers of abstraction. That like, it's interesting because I look at it like, I don't know if anybody's ever wired like a car stereo before, but if you've like rewired a car stereo enough, you can like get a harness that connects to a harness that connects to an adapter that connects to another adapter. And there's a good chance that you could actually just get rid of like 3 or 4 of those that were necessary over time and just connect the 2 on either end together. And that's what I think of when I think of like the modern day stack, is like we've had to go from this adapter style to that adapter style when this was user space, and then we pulled user space away. Now that's user space, and we keep pushing the user further and further away so we can start to standardize things. And anyway, like at some point, like we just need to take a step back and look at this mess of wires and say like, really, we just have 5 wires coming in and 6 wires coming out, and we can probably get rid of all of this stuff in the middle and just throw it away and just make this one clean like connection. And in my mind, that's eBPF. That's going straight from kernel, straight to user space, straight to your application, right? There's no kernel modules, there's no user space, it's just straight in, straight out, like just like clean, simple, just the way you want it.
I'm reminded of some of the like meme style images that are like a Thunderbolt to a USB to like an old style mouse to an old style keyboard to like old serial ports, and eventually it gets back to USB on the other end. And we look at that and think that that's hilarious, and then forget that we actually just do that as part of our daily life as time goes on.
And the beauty of that is, like, this is my favorite part about humans. And to get to that pattern, you never did anything wrong. You never intrinsically screwed up anywhere along the way. You never intrinsically were had a moment of saying that was the bad choice. That overarching bad pattern is a series of correct choices to get to this bad pattern, which is like, that's what I love about it, is you can do the right thing. You can be success. I mean, I just like imagine me like drinking a cup of coffee at work, like I'm the best infrastructure engineer in the world. I've never had anyone say anything bad about me. I've met every OKR. I've gotten all the promotions. I've gotten raises. You know, I'm like big, I'm famous, I'm fabulous. And it's like, but I built this pile of crap. And it's just like, well, that's because like, that's what happens, right? When technology changes, you end up with this adapter of adapters of adapters of adapters. And like, that's, nobody did anything wrong. It's just now we're looking at the whole thing and saying, well, we don't really need these 12 things in the middle anymore.
So are we going full circle then?
Yeah, I think that's the term, right? You go full circle on USB.
So I think that's.
We have a question from the audience.
Yeah.
Yeah. Sorry, Noah, go ahead.
Because the question from the audience sort of ties into this human aspect of, this is how teams evolve, and this is how engineering orgs will eventually adapt it. And I kind of want to focus on that space for a little while, about the really human aspect of how this continues to evolve, because it's always the humans that have to implement all this. But the question from the audience is, have you seen product teams, engineers be the ones to resist the changes driven from the engineers working on the system operation side? And that's like an org question, because it's a human question.
So the question, like, let me make sure I'm understanding this right. The question is, have we seen product management on the infra side say no to engineers?
I think so.
Okay.
That's what I'm getting at.
I think that's probably the question. I think it is, because that's certainly a question we see at Twilio often. And this goes back to the, you don't need a server, you need a database. Which it's just getting good at saying that and getting good at detecting that. That's a skill, right? This is just like basic social skills here, which is like, hey, we need 30, servers in Amazon. It's like, well, why do you need 30 servers in Amazon? Well, we thought we needed 15, but it turns out it's actually cheaper if we get these size versus those size. And so anyway, instead of getting 15, we're going to get the 30 of these. Like, okay, well, what do you need those for? Well, we found out that we need 5 servers of redundancy, and in order for us to run our etcd cluster, it has to be 3 nodes of quorum. So we now have 15 servers we need. And it's like, oh, okay, well, that's $1,000 a month for 30 servers in Amazon. It's like, oh, okay, cool, or however much it is, right? And then it's like, or that's $10 a month if you go and run the managed etcd service. So like it's unpacking the why that they need what they think they're asking for, and realizing that really what they care about is they have an etcd API. And anyway, like I'm a firm believer that SREs and infrastructure engineers are like the Navy SEALs of software management. We have to do everything. We have to do everything everybody else does, but we have to do it underwater with scuba gear on while people are shooting at us in the middle of pitch black darkness, right? Like but like we still have to do the same thing everyone else is doing. And I feel like that's it. We have to be people managers, and we have to be big picture thinkers, and we have to have, really, really intense level engineering insight to be able to not only engineer our systems, but actually have the insight to detect what somebody might be asking for versus what they actually need for the sake of the ecosystem or the infrastructure in general. So I would say the concrete answer to the question, have I seen product managers push back on engineering orgs? Yeah, all the time. Whether it's infrastructure or not, like that's just, you see that all the time. I think a good product manager is just capable of extrapolating, the difference between we need 30 servers and we need, an etcd service, right? And I think a good architect or a good engineer is saying, oh, okay, well, if we need etcd, like this goes back to like if you give a moose a muffin, right? Like, well, if we need etcd, we probably need Kubernetes. And if you need Kubernetes, you're probably going to need a bunch of servers. And if you need a bunch of servers, you're going to need to manage them. And then you're going to need cluster API, and here you go. And so, yeah, I've seen it. I think it's a valuable thing to be able to say no. But one of my favorite things, like if folks walk away from this talk and they remember one catchphrase to bring with them to the office, there is a difference between not right and not right now. And that's like a huge, huge fundamental difference. Like we don't have to say no. We say yes, but in a different form. Or we say yes, and we'll take that into our, this is product management. We'll take that into our next release consideration. We'll prioritize that for our next release. And as it turns out, we're not saying no, we're saying not right now is actually what, an engineering org can take that and work with that. We can take that and buy ourselves much needed time to like not get further into technical debt. And we have, created a clear paradigm of feature driven work that's going to allow us to release the feature as needed. So like, this is why product managers and why software engineering teams work the way they do, is because we need to actually get to a point where we're doing more like SaaS style development but for our infrastructure, where we have releases and we can communicate about those effectively. And that, yes, we understand that your problem is important. Yes, we're doing our best to make you as self-sufficient as possible. However, you're going to have to be patient because that's coming out in 1.1, which will be out in 30 to 60 business days. As it turns out, that release driven, that we have a release coming out, that typically doesn't exist. The ability even to say those words, I found typically doesn't even exist in infrastructure organizations. So that's the change. That is the change in thinking, the change in culture.
And there's a thank you from a member of the audience about the difference between yes and absolutely not, saying that
right.
it took them decades to get that mindset.
Yeah.
Do we have any other questions we want to get to before we move on to our fun sort of rapid fire questions?
I have a question. We have what, 10 minutes left? I'm just keeping an eye on the clock here. Yeah. Okay.
Okay. So there's that. I guess we move on then, unless you have a question?
No, that was it. How much time do we have left was my question.
Oh yes, it's 10 minutes.
Okay, gotcha.
Obviously, we
Perfect.
didn't have enough coffee.
No, why don't you Noah, why don't you run this one?
Okay, so we start with the rapid fire questions, which are designed to be fun. Start with yes or no, pineapple on pizza.
Yes, absolutely yes. 100% yes. And everybody out there who knows I'm talking to them, the answer is, oh yeah, all day, every day. Not only that, upside down pineapple on pizza. I'm all about it.
Upside down?
Next level. Upside down pineapple on pizza. I love it.
Okay. Favorite climbing spot?
Ice. Anywhere there's large amounts of ice. My favorite route I've climbed is the Couts Icefall on Mount Rainier, probably. Although some of the routes in Iceland are just it's just a different experience. Maybe Skaftafell is another good one.
Awesome.
Yeah.
You want to go? Favorite hobby besides climbing?
Favorite hobby besides climbing? Does computer science count?
I mean, I guess it can. Sure.
Yeah, I mean, because like here's the thing though, is like I found out that computer science holistically was also a means to an end for my career to survive capitalism, but it also was something I did for joy. And now like I've done a good job of compartmentalizing this activity. May or may not be using the same tools and technology I use at work, but I will be doing this activity for fun. And I approach that dramatically differently than I would approach like a work related thing. And being able to do that took a long time to learn that skill, and being able to compartmentalize that for myself took a long time to learn that skill. And anyway, it took me 10 years to went from I love computers, everything computers, to I can't believe this industry hurt me so bad that they took away the one thing in this world that I loved from me and turned it into like this bittersweet paycheck driven, like whatever. And now the thing I loved is now the thing that hurts me. And how dare you traumatize me like this? And I've gone from that to like, well, as long as I compartmentalize it, as it turns out, working on the kernel is actually fun again. So that might be my second hobby. And if I had to pick one other than that, other than climbing, photography. I love photography. I love taking pictures.
Sweet. Didn't know that.
Yeah. Today I
Yeah.
learned. Favorite instrument? Because
My guitar. My guitar. I have that's that thing right there.
Okay, awesome. Favorite open source project?
Of all time?
Yeah. Or current. You could do maybe both.
Wikipedia. Wikipedia.
Nice.
There is
Good answer.
there is so much more to Wikipedia than what people think there is. It is truly the collaboration over competition experiment that this world needs. Like it touches economy, it touches, you know, the political nature of every country. If you voted, if you've been pissed off at politics in the past like 10 years, Wikipedia is concretely related to every experience you've had, because it approaches the problem of managing people in the name of collaboration and kindness is more valuable than competition and self-interest. It fundamentally breaks capitalism in an economic standpoint, and I can love it. All about it. I want it more. More Wikipedia, more open collaboration, burn it down. We need to start being nice to each other. And I think Wikipedia is just the living, breathing example of that working, and I freaking love it.
I love that.
Me too.
Work you've done that you're most proud of?
Work I've done that I'm most proud of. NAML. I hate to say it, but like this, it happened like over the past few weeks, and it's been totally like, it started out as me just getting frustrated, and I didn't even realize this was such a thing that people didn't realize was an option until I like actually started writing it down and people started to like react to it. But I'm all about giving people patterns in software to make themselves self-sufficient. Like, right, that's what we've been talking about for the past 30 minutes. And the moment I realized that there was an opportunity for people to like learn, not only learn a life skill in writing Go, but like also like solve like a huge problem in the ecosystem. Like I just, that's like a good win-win. That's like one of those like few times in the world where it's like, not only did we provide power to everybody in the middle of the desert, but we also created drinking water. As it turns out, dams are a really important thing, right? Like it was just kind of this win-win that solved a bunch of problems that like made everybody happier and didn't really have too much of a dramatic impact other than, you know, killing a bunch of wildlife and like ruining our deserts, but like, you know, whatever.
It's awesome. For the sake of time, today is we're going to be making a contribution to a charity, and this charity in specific you have something to do with. Can you explain and maybe talk about your charity a little bit just so people know?
Yeah, so okay, for the record, this is my first time ever publicly talking about the Privilege Escalation Foundation. So we have a few minutes here, so I'll just be quick, because I actually, and this is like, first off, let me say, if anybody out there knows anyone who wants to do like a podcast or a video or an interview or whatever on the specifics of the charity in general, like please reach out to me. I'm great at this stuff, if you can't tell. So I would love to talk more about it. But I have been dramatically hurt by private healthcare in this country. And it's, I say as a transgender person, I've been hurt, but it's not because somebody woke up one day and decided that we hate all trans people and we're going to like go out of our way to make it hard for them. And we have this secret agenda and ample free time and available emotional resources to go hurt people. It's just because people being transgender has just been misunderstood. And with that misunderstanding comes neglect. And so like, yes, our healthcare system is not structured in favor of trans people, but that's not because people are out to get us necessarily. I mean, sure, there's some of those out there, don't get me wrong, but like, it's mostly just because people don't understand that this is something that people need to be healthy and to be happy. Most people view healthcare as like, I got sick and got strep throat and I need a doctor, not as I'm gonna go kill myself if I can't adjust my endocrine system to stop me from going through puberty. That's just not a thing our society talks about often enough. So anyway, because we're in that situation, I found that a lot of trans people are ending up hurt. They are ending up dead. And a lot of them are brilliant people. And so I started a nonprofit that, again, this goes back to Wikipedia and burning down late stage capitalism, that we're not for profit. I don't want to make a profit. Kindness and collaboration is more important to me than making money. I want to just give money to people. And so anyway, as it turns out, other people have enjoyed that. And I have a particular set of skills to enable this. And I decided that solving the world's problems was too big of a thing for me to bite off, but I can certainly solve a small amount of problems for a small group of people, of transgender people in science, technology, education, and math. So the idea is that if a mind is beautiful and a mind is brilliant, it should never be held back by the constraints of its body. And that's what the nonprofit aims to do, is we just make the problem of private healthcare as it appears in the eyes of a transgender person go away. If you need HRT, we'll pay for it. We won't touch insurance, we'll just pay for it. If you need facial reconstructive surgery, if you need gender reassignment surgeries to keep you from killing yourself, to keep you from being happy, to turn you into the person you need to be, to even make the money it would require for you to have this surgery, we'll write the check. And that's literally all we do. We have a Discord, we hang out, we have a set of policies in place that like enable this. I manage the money. I never decide where the money goes. We have volunteers who have taken time out of their day, and they have a rubric they put together that says what we look for and how we give money away. And right now our operating costs are like $100 a month. And every dime we get just goes straight to trans people. And anyway, it's called the Privilege Escalation Foundation, which if you know anything about me, you'll find the irony in that name. And doesn't matter if you can give $10, if you can volunteer, or if you just want to share the name, it's super helpful.
And is there a website people can go to donate and help out with this?
Yeah, privilegeescalation.org.
Sweet.
I'm heartwarmed.
Yeah. Yeah.
It's wonderful.
Thanks.
We're coming up on time. We have a couple of questions in the Q&A that we didn't get to because they came in near the end. Kris, would you be willing to maybe hop over to Twitter and we could take care of some things over there?
Yeah, I can hop on Twitter. I will say that right now Twitter has my account marked for like, click here if you want to see this because it might contain sensitive content or something. So like I'm working on getting that taken care of. But yeah, I'm happy to hang out on Twitter or Slack or even here. However you guys want to do it. I think I'm free for the next few minutes.
Awesome. So we'll take the questions that were there. We'll bring it over to the @StormforgeIO Twitter so people can publicly see whatever the answers are, and we'll take it from there. Thanks to everyone for coming. As all of your attendances help benefit the charity we were just talking about.
Thanks everyone for coming. I do appreciate it. Thanks for having me. It's been great to talk. We should do more of these. This was fun.
Thanks. We'd be happy to have you back anytime.
Cool. Count me in.
And I'm going to stop recording now.